roundtable, the first roundtable of the day, which will address the digital transformation of EU industry towards a sustainable, resilient, and human-centric industry. We have spent most of the morning talking about Cluster 4, and it is this Cluster 4 the one supporting the development and mastery of digital and key enabled technologies of the future. This will allow the EU to increase adaptability and resilience to improve production response, recovery, and preparedness to deliver on a green, digital, and fair transformation. The EU, through different funding programs, will support the development of key enabled technologies that are strategically important for Europe's industrial future. So this roundtable will focus on some of these key enablers, the opportunities and challenges to drive related research and developments, and also the support needed for its adoption by industry and SMEs. To this roundtable, we have Felipe Gil from University of Vigo, Selma Kshir from CIA, List Institute in France, Andrés Gómez from CESGA, Galician Supercomputing Center, and Eugenia Mijares from the Digital Innovation Hub of the Galician industry. Hello to you all four. Thank you very much for being with us today. So we will start talking about boosting the potential of industrial digitization with 5G. And for it, we have Felipe Gil from University of Vigo. So Mr. Gil, whenever you want, all yours. Thank you very much.
So thank you very much. As you said, I am Felipe Gil from the University of Vigo in Spain. I am a researcher in 5G technologies and mainly in the application of these technologies to the flexible, to the flexibilization of these technologies and the application to different verticals. Also, as you said before, I think I can also speak in Spanish, so I'm going to change because it's going to be a bit easier for me. So if you don't mind, I'm going to proceed. Así que cambiando, pues como decía, estoy enfocado en esa aplicación.
I am focused on this flexible implementation of 5G technologies, and one of the targets of this flexible implementation is industry, because industry has some really interesting challenges for these communication technologies, and there's many cases of use that cannot be implemented unless we are using this type of fifth generation technologies. Industry, so far, has been able to create great volumes of production. That has been one of the great innovations of the 20th century, being able to produce great amounts of products in large series and making them much cheaper. This is something that this has allowed for us to have the consumer society has been possible thanks to this, but we have got to a point that the system used by these industries is reaching a limit. Until now, the optimization these industries have achieved to produce more and better, finally it consists of producing faster with better quality, or even personalizing each product to the needs of each user. The cheapest production is achieved thanks to this faster production. And here we're reaching a limit where European industries cannot compete against it, or they compete with industries from other countries, such as the great Chinese industries that are achieving much lower prices. So in this context, for the last a few years ago, we proposed the creation of the 4.0 paradigm in the industry, in which we're looking for mechanisms for the optimization, for automatic configuration of automatic diagnosis of systems in order to avoid problems, to avoid halts, to improve the efficiency of machines, and also mechanisms that allow workers to work more efficiently in these environments that are becoming more and more complex. In this new paradigm, one of the practical issues is flexible production. Production strictly what is necessary, adapting each product to the needs of each customer. This transparency is intended to illustrate this. We moved from creating great amounts of products which are as similar as possible in order to avoid changes in the line of production. Now we move on to this production, which we denominate almost unitary production. We starting to produce very, very small series, or even a series with just one single unit, which is optimized, adapted, customized to each one of our customers. So instead of competing with prices, now we are competing with the adaptation to the specific needs of each one of the consumers of the products. In any case, we need technologies that allow for this production, this new adaptation to the needs of the users, even the quality control of each product. We must make sure that this does not affect the price. This paradigm should be implemented without generating any cost increase. This is where the fifth generation communication technologies have a role to play. The 4.0 paradigm in the industry includes many concepts, from Internet of Things to cyber-physical systems, the digital twin, which allows us to see the situation of the production, or even doing simulations, mechanisms of decentralized decision-taking. We have many components that are working all together. And we have to make all these components work together. And one of the technologies to allow for these components to exchange information very quickly are the wireless information technologies. And within these wireless technologies, we have the 5G technologies and the future generations that will come in the future. These technologies allow us to guarantee there will be a quality communication. There will not be problems of disconnections, of latency. These provide a series of benefits as opposed to the previous technologies. And the 5G technologies, the technological context of the fifth generation, does not only bring us the wireless communications, but it also brings other paradigms or ideas, edge computing, for example, which are also very, very useful in these scenarios of 4.0 industry. If we focus in the part of communications, for example, here I want to show in this introduction to the use of 5G, I just want to show you a general idea of how these 5G communications can be implemented. Maybe it could just be related to the shipping and reception of goods or the management of logistics, but they could also be applied to environments with strict requirements. So, for example, the relationship between the robot control system and the robots themselves. So we can't, in cases in which we cannot allow for any data, any millisecond to be lost in the communication with the robot, because if there was a mistake, there was a delay that could cause a mistake in the production. All these technologies that are not strictly communication technologies, but they're concepts that provide solutions in the industry. I'm talking about edge computing, multi-axis edge computing, and its industrial implementation. All these technologies that we're using, we have on the one hand the Internet of Things, the control systems, and all these concepts. And at the end, we need a system of computation for verifying the pieces in real time to detect any kind of anomalies, and we need a counting system that could be deployed in the factory, and that has its advantages and its disadvantages, because deploying computation equipment next to the robots, it uses power, it uses space, and if we want to reconfigure the factory physically, that implies problems, because maybe just installing a cable, that could cost time and money. We also could deploy the cloud technologies, but many of these applications have a very strict real-time requisites, and these latencies could be unacceptable. That is where the edge computing concept is useful, because we can apply this in the 5G network and we can have them close to the factory. On the one hand, we have the flexibility of not having the service installed in the factory, but also having low latency. I have a video that shows these advantages. I don't want to take too much time, so I think I could stop here, and if we have time later, I could introduce the video. Or maybe in the question time, if anybody is interested, I could show it then. Thank you very much, Felipe Gil, and we're going to wait for the intervention of all speakers, and then we will see if we have time for
to
anything
address
else.
how artificial intelligence and robotics are transforming the industry, please welcome Selma Khir, Research and Development Project Manager from CIA, List Institute in France. Ms. Khir, you have the floor whenever you want. You have just to switch on your camera and switch on your sound, and we will listen to you. Thank you.
Thank you very much. My name is Salma Khir, and I'm a researcher and project manager at the French Atomic Energy Commission, CA, and I'm going to talk about how artificial intelligence and robotics are transforming the industry. So I would like to start with a funny picture that I found about the types of robotics paper. As we can see here, there are different types of publications. Among them, there is this interesting statement, titled about a paper, about human-robot interaction in an application no one would ever use. So this is really a motivation to focus on industry-driven research. So we are not doing research for proving fantastic things if they are not useful for the industry. And we believe that creating working groups and digital innovation hubs can play a crucial role in bridging the gap between techno providers and end users. There are also other papers about applying machine learning, for example, to solve a problem, but it does almost as well as a solution that is usually used. So this also highlights that trustworthiness is a key factor for technology adoption. And for this, we need to work on failures prediction, AI explicability, algorithms performance. Also, there are other papers about finding very innovative solutions, but the problem is that the cost is too expensive to produce and to be used by the industry. So the industry needs to make benefits from investing in the technology. And this goes through studying the ROI and business models at the early stages when we do research. And finally, I found also this interesting, having results that perfectly work in simulation and they don't work in real life. So we need to improve reliability, and AI needs to be conclusive on real use cases. So at CEA, one of our main objectives is to bring research to the industry We are 20,000 employees working with 200 industrial partners in 38 different industries. We created in the last decade 26 startups, and our technologies are deployed in more than 40 countries. We play a double role as first as service provider for accelerating the introduction of new technologies, and the second role we act as an innovation orchestrator at the national and European level. We are responsible for the coordination of Factory Lab community, which brings end users and technology providers to find together solutions that are suitable for the industry. We are also one of the founding members of EIT Manufacturing, and the headquarters is located in our premises here at CA. And we also created Floor, which is a physical platform for SMEs for testing solutions in realistic conditions. Here, I just wanted to give an overview about the needs for AI and robotics in industry, because when we think about AI and robotics, when we think about industry, we think about manufacturing in the first place. But there are also many other applications in agriculture, for example, and in healthcare. Here, there are some examples. So in manufacturing, we can use AI and robotics for improving flexibility, smart work, rescheduling or the scheduling of the resources and dynamic reallocation, for example, of these resources. In agriculture, we can work on animals welfare, soil compaction, for example, with smart algorithms for navigation, weed destruction, and there are many applications. If you would like to learn more about this, there is the GIH, AgroBoFood, and ESMERA experiments about agriculture. So there are EU projects. Sorry, I didn't include the links, but I can add them afterwards. So you can find many applications that implement AI and robotics in these fields, and also about healthcare with GIH Hero. So what AI and robotics can bring to the industry? First of all, learning abilities, learning from the interactions. So for example, we can imagine that the robot is able to learn from its interactions with the environment and with other robots, with the humans also. Vision to recognize localized objects in the environment, and to recognize new objects very easily with very few data about the object. Human profiling in terms of, for example, we are able to understand the preference of the humans, their profile, their behavior, their fatigue. For example, we can detect the fatigue of the human operators, so we can adapt to the rhythm, the cadence of the production. Control, it's also we can tune the gain or monitor the accuracy of the robot. Situation awareness, for thinking about a situation, analyzing a situation, expected or unexpected, and being able to act accordingly. And then machine tuning through gesture recognition and natural language processing. So for example, from speech to text, from text to models, and so on. I would like to show some examples. So here, ideally, we imagine that we ask the robot to do a task and he solves the problem using its own skills. And if we want to grasp objects, instead of pre-programming a trajectory, we introduce a limited data set of manually specified expert grasps and metrics for quality of grasp, in addition to the gripper configuration and the localization of object with vision. And we are able to automatically generate optimal REST flows. So here we can see different configuration and configurations, and each time the robot is able to adapt for grasping the part. The second example that I wanted to show is related to AI for human profiling. So here we have on the top left, we can see an image from the report of the International Federation of Robotics that presents different human-robot collaboration applications. And here we can see the most collaborative applications are this type today, coexistence, so the robot and the human are sharing the same workspace, or they work with sequential collaboration. And in the mid-long term, we imagine that we need responsible collaboration between the robot and the human. So the robot responds in real time to the movement of the worker. But to do so, we need to understand what the operator is doing, what the human is doing. So here I have two examples of two humans doing the same task. On the left, the human is not really used to the task. So he is not an expert in this task. And on the right, there is a human doing the same task, but he is being disturbed by a colleague who discuss with him. And when he will restart doing the task, he will make a mistake. So I need to speed the video a little bit, but we will see. So instead of continuing the task, he restarts the task from the beginning. So in order to adapt the task to the profile of the operator, we need to analyze the movement control, the robot mastery, the effort control, and the rapidity of each single operator in order to deduce the level of expertise. And this goes through two steps. So analyzing raw signals to human skills level, and in order to provide a personalized assistance for the operator, by combining statistical and symbolic artificial intelligence. So this work has been validated on 22 volunteers in real settings, and the assistance to the operator have shown that the operators who use the assistance have improved skills, more closer to the expertise level that we can see here. So there were several wakes in the last century. Sorry, I don't know if you can see, but yeah, I think. So there were several waves in the last century. There were Macintosh, the smartphone, and now there is the coming wave of Industry 5.0. The industry of the future needs to adapt quickly to changing circumstances. So for example, production needs, we don't have a single robot anymore dedicated to a single task, but we need to adapt the robot to different tasks to be able to reconfigure very easily the production system. We also need to adapt to vulnerabilities that can occur on many levels. For example, the pandemic has shown that there are strong dependencies on the supply from suppliers from suppliers, and this caused different hard consequences. Sorry. So we need to rethink the production process with respect to environmental and social impacts. So industry may lead to green transition, and industry workers may see their role changed. They may work on different tasks, and they can be empowered to improve their skills and so their expertise is really needed in the industry. So to succeed to do this, what do we need to do? We need to, first of all, encapsulate complexity, hide complexity, so will ease the reconfigurability. We need to implement holistic digital twins. Digital twins that are able to describe what is happening, to predict what is going to happen, and to solve the problems, and to improve human-robot collaboration. So by focusing on the human profile. So the technology is not here. So we don't need to adapt to the technology anymore. The technology needs to adapt to the human needs. So I would like to show two videos, to finish my presentation with two videos about AI and robotics for assembly. So this is an example from a project called Robocompagnon. It's an internal project at CA that I'm honored to coordinate. It gathers 10 laboratories from CA, and it implements different technologies to prepare the future companion of the human in the factory. So here we can see. Oops.
Excuse me, Ms. Selmaksir, sorry for the interruption. Just to remind you that we are a little bit late, so if you can make it quite short, your presentation, we will appreciate, because we have another two speakers.
Okay, sorry.
Thank you very much.
Okay, so very quickly then, just this is a very an example of an assembly. So we have randomly placed parts in an assembly area, and we have different technologies to coordinate the assembly. So here we have the system orchestrator that is able to, responsible for coordinating the assembly sequence. And here the vision system can recognize, localize the parts. The digital twin is responsible for generating the trajectory in order to grasp these parts. And so the other example is very quickly in 30 seconds. What happens if something goes wrong? So we need to call for human intervention. We need to understand that something goes wrong, and we call for human intervention, for example. And so the human can intervene, and thanks to the gesture recognition, we can know what happened in the task. And the system can resume when the human stops. So thank you for your attention, and sorry for being.
It's okay. It's a very interesting intervention, but unfortunately we have a very small time for this. So we continue. Thank you, Ms. Selmaksir. Now we are going to focus on infrastructures, specifically in key infrastructures for support, research, and digital transformation. For it, we have Andrés Gómez, Application and Projects Department Manager at CESGA, Galicia Supercomputing Center. So whenever you want, thank you very much.
Thank you very much. Good morning or good evening for some of us. And thank you, Feiwa, for inviting me to deliver this presentation. I try to speed up a little bit my presentation so we can recover some minutes. First of all, only to introduce why we are here. Maybe you know CESGA. CESGA is a supercomputing center in the northwest of Spain. We are in Santiago de Compostela, just close to the University of Santiago. And we started our work more than 27 years ago with the idea of providing services initially to the academic sector, to the universities and research centers. But we are focused now in providing this infrastructure and helping the small, especially the small companies, to use this infrastructure. So you can see that our mission is to provide, well, in fact, is to contribute to the advance of the science and the technical knowledge in all the environments, in the ecosystem, applying high performance computing and communications but always in collaboration with other institutions in order to deliver profit for the society. And of course, using this, well, not using, if not following this mission, we provide a lot of services that are related with the use of technologies, these high performance technologies in different applications and in different situations. Let me recover three main challenges that we think that we have to afford in the near future. The previous presenters, not just in this session, if not in the other sessions, told us that we have to use for the new industrial 4.0 and maybe the future 5.0, we have to use data, we have to use twins, we have to use artificial intelligence. In order to achieve a successful result in these areas, we have to cope with the very large amount of data that is called usually big data, okay, that are produced in the factories, that are produced by the consumers, that are produced during the logistics, during many steps of the value chains that we have in our products or our services. Also, Industry 4.0 is based in modeling using digital twins or modeling using machine learning techniques. And these needs, if you want to have a very good result, you need to have infrastructure there to help you to develop these models to get really something that works later in the factory, close to the factory, in the edge, as was presented before, or remotely in a cloud environment that you can deploy and connect with the companies. One of the biggest challenges that we have in the next year is how to use artificial intelligence in the factories or in the process of the industry. But machine learning in many cases imply to use big data. This means a lot of data to process that you must collect in your factory or in your products, and get new knowledge or get new ways of predicting things using this data, using machine learning or deep learning models, or maybe other techniques from the artificial intelligence area. But if you want to achieve really very good results or be competitive with others that are producing these kind of systems, you need their infrastructure to store the data, this amount of data that usually are very, very huge. We are talking with amounts of data bigger than terabytes, close to petabytes. And also you need one infrastructure to process this data and generate the models and find the best model that you can use later in your system. And finally, if you want to be competitive, maybe you want to explore new technologies and how to apply these technologies for your problems. And for example, now we are involved in the new computing paradigm that is the quantum technologies from the point of view of communications and from the point of view of computing, and maybe in the new type of sensors that we are that the world is calling as quantum sensing. Because really, these infrastructures are complex and are large, and you need to maybe access to a remote or an infrastructure that is well managed. The European Union is supporting currently many different projects in order to build this infrastructure from the point of view not only of the computing power, if not already, but including also the support and the development of the applications that are needed to create, for example, the digital twins. This is a full ecosystem of projects and infrastructures that, with the idea of providing high performance computing, this means computing that can deliver really good performance in order to simulate your processes. And also that analytics that is going on HPDA, that the idea is to process this big amount of data efficiently. So you can deliver or you can produce your own models. Inside of this set of projects, CESGA is involved in two of them, that is, for example, this one, that is EuroCC, that is a very big project where we have at least one supercomputer center per country in Europe, with the idea of creating national competence centers that can help the researchers and the small companies to use this infrastructure, and also provide them with access to this HPC or HPDA infrastructure in order to test the new ideas, in order to use for creating new products or new services. The second project that is running now, and we are involved, is this one, that is FF4USPC. This is a project that is funded by the European Union and is led by HLRS, that is a supercomputer center in Germany, and with 5 partners, additional partners: Arthus, ARS, CESGA, Cineca, Escapos, and Teratec. The idea of this project is to bring this means to use the power of the supercomputers in order to lower the barriers of using the HPC infrastructure and create new services, to create new products. The idea is to is based on open calls that we, in fact, we have closed just now the second one in September, in order to fund small experiments where the SMEs can collaborate with other companies or institutions that to test if the HPC can help them to solve their problems in the factories or in the creation of new products or services related with manufacturing initially, but also in other sectors that can have large impact at the European level. For example, in the last call, in the second call, that is now under evaluation, there were 74 proposals from more than 27 countries around Europe. So we think that is really a success open call because these numbers are really very large for us. Currently, we are running 16 experiments that were selected in the first open call. And in the web page, you can have information about more than 100 experiments about how to use HPC for solving SMEs problem. And finally, because we are late, let me check the new future. There is quantum technologies. In the European Digital Europe, the idea is to develop the technology to create the future quantum internet. That is defined like the distributed quantum computers and quantum sensors interconnected via quantum communication networks. So this is a future, but we are in the early stage, so we have to test, first of all, where these kind of technologies can be used. For example, CESGA is participating in this project that is NIAS QC in order to test or to explore the usability of quantum computing in different industrial and use cases. You can see there in red 2 of the projects that we are collaborating with the University of Coruña and HSBC, one of the banks, in financial application and using artificial intelligence, but powered by quantum computing for breast cancer detection that my colleague presented a couple of hours ago, so I don't have to present more. And that's all. I think that you can understand better now the need of the infrastructures and why you need to think about using them.
Thank you very much, Mr. Gomez. We keep on. And finally, to talk about facilitating the option and best use of digital technologies, we have with us today Eugenia Mijares, Public Affairs and Development Manager at Digital Innovation Hub of the Galician industry. Ms. Mijares, whenever you want, we will listen to you.
Hi, everyone. It's my pleasure to be here today with my colleagues from the University of
Excuse
Vigo.
me, Ms. Mijares, we cannot see you. We can hear you, but we cannot see you. I don't know if is there any problem with your camera?
I try again. Okay, the camera is on. It seems so. I try again.
Okay.
Okay, maybe now?
Yes, yes, we
Okay,
can see you.
sorry.
Thank you very much.
Sorry, thank you. So I'm glad to be here. The University of Vigo and the Supercomputing Center are members, both of them, of the Digital Innovation Hub. And I would like to speed up and to use only 5 minutes to explain a little bit what is digital and why are we here today. So this is my favorite sentence, that digital transformation is not an option, it's a reality. And the key of this transformation for the industry is the speed of it. And digital borns only to boost the digital transformation of the industry. This is our main goal and is our main concern in every activity. Here are some features about digital. We are a hub. We are a meeting point for the industry. We are industry. We are integration. We have a lot of partners, as I said before, the University of Vigo and the both universities of Santiago and La Coruña, the Supercomputing Center, the technology centers, private companies like Siemens or Vodafone. So we are industry and we are all the partners and all the technology linked to the industry, integrating all of them. We are based on value change projects. At the very beginning, my colleague from the University of Vigo talks about Industry 4.0. The projects developed by our members working around value chains are a big access for us. And we are focused on companies' needs. You can see the numbers here, more than 300 SMEs, turnover almost 20,000 million of euro, and over 50,000 employees in the industry. I had a video, but I think it's better to go ahead. So how are we facilitating the adoption and best use of digital technologies? We had first main task. The first one linked to build the ecosystem, the second one linked to the challenges of the industry, and the third and last of them, but maybe the most complicated, to organize the tools, the capacities, the infrastructures, and the services. You can see here a picture of the ecosystem. We are putting on the center the industry need, as I said before, and we have a lot of stakeholders surrounding these needs, focus on these needs. We are focusing in three mainly technologies. We don't like to talk about technologies because we are industry and the technology is a tool from our point of view, is a tool to improve the industry competitiveness and innovation through the innovation. But really, there are three technologies that are very, very important for us. These were mentioned before: artificial intelligence, cybersecurity, and big data and supercomputing. We put together the technology demand with large companies and SMEs, and the technology supplied with the representative of the competence centers, the lab technology companies, incubators and accelerators, and so on. So our goal is to place the industrial companies in a position of competitive leadership at a global level through the innovation and the digital transformation. This is made based on a collaboration environment using all the capacities in the ecosystem. We have here the heart of the digital, of the hub. We have an assembly, we have a board. You can see in the board that the main representation in our board of directors is the industry. We have obviously a representative from the ICT sector, the cluster, and Bosch company, and so on. And we have the hub team and the demand group and supply group. For us, this the previous image of digital, that is the ecosystem, is here on the floor through phases and through the demand and supply group. So these are the members of the both groups. For us, they are the tractors and the main agents in this project, and we have, as you can see, a broad range of agents representing the whole ecosystem. The second task was to fix the challenges. These were really difficult, and we are very happy about the result, because we have three main challenges to facilitate the company's and digital transformation. We have the people, the digital transformation soul. We have the industry, the digital transformation body, and we have the environment, the link between digital and green. In terms of people, we have three challenges of main areas to work. That is the data-driven decisions, the smart office, and the human-machine interaction. In terms of the body of the industry, we have virtualization, simulation, and advanced automatization, robotics, and so on, traceability, quality, and security. And in terms of digital and green, for us, it's very, very important to link the digital and green. It's not only to talk about energy. Obviously, energy is very close linked to the sustainability and the environment, but the main areas of the digital transformation are linked to the sustainability, and they have an impact, a direct impact in the environment. So in this third challenge, we have a smart logistics, integral value chain management, and the challenge zero waste and zero emissions. The tools. Okay, we organize the tools to facilitate the digitalization of the industry around the services of the hub. So we have five main areas. The hub is the European Union defines the hub as a one-stop shop where the companies go and with a problem or without to know exactly what is the problem, and they are going out with a solution. The solution normally is a connection, a project, the use of an infrastructure, a training. It depends of the needs. So we have five main areas of services, with the industry challenge in the middle, in the center. And we have a main area related to ecosystem innovation and network. For us, this is basic, the connection. We have another area that is technology innovation linked to test before invest, proof of concept, and this kind of solutions, the use of infrastructure and the use of the market solutions linked to ICT and digitalization. We have another main area that is skills. For us, the training is very, very important. The people is in the center, and for us is so important, as important to develop new technologies or new application of these technologies as to develop the skills of the workers. The funding search is another area for us very important, linked to the optimization of the public funding and the connection with the private investors. And the last one is the new digital business model. It's not time to think about how to put the digital tools in my traditional business model. It's time to create new business model that can born as digital from the very beginning. An example of how we align the challenges and the projects, recently we collaborate with the GAIN, the Regional Agency for Innovation, in a program called Connecta Hubs. We were connecting the ecosystem, and 8 projects were approved with 32 companies involved and with 7 million euro mobilized. And another example of our concept of the ecosystem and the need to facilitate the collaboration to boost the digitalization is our European focus. From our first idea 3 years ago of the hub, we have very clear the idea to connect the whole Europe. So we have the connection with this hub from the very beginning. You can see the image. We cover the whole Europe, and we are very, very close of them. And recently we received the recognition as Gold iSpace by the Big Data Value Association. So for us, this is another way to be connected to the main actors in Europe linked to big data and to artificial intelligence. And our next challenge is to go on in the connection, connecting the ecosystem, the technology demand and the technology supply, and to achieve the recognition as a European DIH, because we have the recognition at a regional level, we have the recognition at a national level, and we are working in the new recognition for the whole ecosystem and to achieve a better connection. Thank you very much.
Thank you very much, Ms. Mijares. Now, I know we are late, but I wanted to know your opinion about a couple of questions. So I would like to ask Felipe Gil, Selma Xir, Andres Gomez, and of course you, Ms. Mijares, to switch on your camera and your microphone. Thank you very much. This question is for all of you. If you want, we can go in order. So I would like to ask you, from your experience, what are the main characteristics of those companies or industry that succeed in the digital transformation? What are the main obstacles in your opinion? So if please Felipe Gil can answer the question, I will appreciate.
Well, it's not an easy question. I mean,
yes, are two questions different. Yeah. So what's the obstacles and what is the secret to succeed in this area?
I cannot answer the second question because it's too hard. It's probably, I mean, if I knew the question, I would be probably very rich. But regarding the first question, which is more technical, I can answer that. I mean, the obstacles, there are many. For example, for digitalization, of course, the uses, I mean, the tradition in the companies is a stopper, because also digitalization requires an effort to change. Fortunately, now companies, from my point of view, most of them are aware of the need of the change. So that is the first point. And also there is, I mean, the technologies are complex also, so sometimes they require help, but I'm sure that all the institutions that are here can help in that.
Selma Xir, I don't know if you can help us, if you identify some of that aspects that Mr. Gil was indicating.
Mm-hmm. So the obstacles maybe can be related to awareness. I think technology awareness. I think as Mr. said, the key for success, in my opinion, from my experience, is that to have clearly defined needs. So a company have clearly defined needs and ideas. And generally, the big companies are divided into R&D teams and business units. And the R&D teams try to explore different solutions and then try to convince the business units that the solution can bring benefits to the company. So it's adoption. So it could be a good way to do things. So, yeah.
Okay, so Mr. Gomez, I don't know if you agree with what Ms. Gishir has said.
Well, I agree with both of them, but I think that, in my opinion, the key points to have a successful deployment of technology is the first one is to have the support of the managers, of the president or the managing director of the company, that this person must support and must push the digitalization. The second one is not related with the technology. The second one is to write or choose the right problems that you want to solve and select the best technology for solving this problem, and not the opposite that sometimes occurs, that is select the technology and look for a problem later inside the company. In this case, maybe you will fail in the future. And after that, technology, you have a lot of technologies. Some of them are complex, and for the reason, the best thing is to find for people to help you to deploy the technology.
Ms. Mijares, your opinion, please.
I add one thing to the last comment of Andres. I totally agree with my colleagues. For me, the key are in the mindset, in the change of mindset in the companies, to be focused on the company's needs. The second one is this matching that Andres talked about, is this connection, mindset, connection, and funding matching, because sometimes the companies need to encourage to develop a project, and normally if the funding is very well matched, it's easier for them.
Well, the next question is more or less related, is what would be, from your point of view or your specific area, the key elements for placing EU industry at the forefront of digital transformation? What are the homework does Europe have? So Felipe Gil, I don't know, what do you think?
Okay, yeah, I will talk about my my areas of expertise. So again, I think that we need to be leaders in the application of technology to the industry to be positioned at the best place in the competitiveness at a world level. So be early adopters and use the technology to optimize the factors, the production, and so on.
Mm-hmm. Mr. Gomez?
Well, really, I think that Europe is doing now a lot of things. In fact, the Industry 4.0 was more or less defined here in Europe in order to recover the lag that we had with other countries. And I think that we are doing right the work now. But I think that we have to do more, and we more innovative to develop more products and to develop our infrastructure in order to have this well-known word that is sovereignty. We have to recover many things that are outside Europe and have here this kind of companies and services and infrastructures.
Ms. Gishir, I don't know, what do you think is more urgent to develop?
I think it's important to work together. Digital innovation hubs can really help for this, because we have access to different competencies around Europe, and we can have complementary competencies to think together and to prepare together the future.
Ms. Mijares, in our questions and answers, one of the participants says, in my opinion, the success is to be in a technology state of mind. I don't know if you agree with this idea.
Yeah, okay. As I said before, we don't like to talk about technology specifically, but I totally agree with the bottom of the opinion. That is, we need to change our mindset. And for me, the key of the success is to put. Sorry, I'm repeating myself.
No problem.
To use the industry or the companies as engine, and to put all the fuel and all the materials that you need to support them in the implementation of the technology. And Andres before talks about the initiative in the European Union looking for the sovereignty of Europe in some kind of technology. They are strategic in terms of not only in terms of independence, but in terms of leadership, and this is our goal. So for me, it's important that this development is at the same time that the industry needs. I explained before. Sorry, you put the industry need, and you achieve the technology advance linked to this industry. So it's the perfect mix, because we have the two legs of the leadership at the same time, developed at the same time. And now I think we have a little bit, one leg is shorter than other.
And the other. Okay, thank you very much. I don't know if any of the speakers want to add something. I know we are late, but if you want to add something. Okay, so thank you very much, the four of you, Felipe Gil, Seg Mashir, Andres Gomez, Eugenia Mijares, thank you very much for this roundtable, and we will continue at 3 p.m. Thank you very much.